morning, everyone. Today here we have Davy de Mits.
Morning.
And myself, Stan van Hoof. We are both part of the new technology team at Exclusive Networks. So today's session is mainly about technology, and that technology has been around for a few years now. But we think that the time is right to introduce this to our markets. We will talk about how attack surface management and more specific about breach and attack simulation. We will end with introducing the vendor we have chosen to address this topic. Of course, you can see it by the logo that this is Cymulate, but we will do also more in-depth sessions later on that are more vendor specific. But today, let's gonna start with identifying the problem and finding the right use cases to use this type of technology. Davey will do a quick demo, of course, to pique your interest, but we assure you we will organize more deep dive sessions, both technical and sales, later this year. So let's get started.
All right. So we're going to start off with showing a few, explaining, let's say, a few terminologies. Because, of course, when we're talking about this subject, a lot of terminologies will be shown and will be shown to you. And it's important that you understand what we're talking about before we continue. We're all familiar with a few terms that we know from the past. If you've seen our previous sessions, we have done a lot of work on the MITRE ATT&CK framework, which is describing how adversaries work using the tactics and techniques and procedures, the tools that they have. So whenever you're talking about the MITRE ATT&CK framework, it's really about the different techniques that an adversary is using and that APT groups, advanced persistent threat groups in the wild, use to actually perform attacks on your organizations today. They use these different tactics and techniques, and these are documented well in a framework in order to allow us as cybersecurity experts to actually talk to each other and then talk about these things in the same language, make sure that we understand what kind of techniques they're using, what kind of tools are in the wild. So APTs, TTPs attack are really about this, and it's important to understand this because this is exactly where adversary simulation or breach and attack simulation is all about. You probably are familiar with the term vulnerability assessment, VA, which means it's really about identifying any vulnerability in your environment. The tools that do vulnerability assessment basically scan your environment and they monitor, let's say, the attack surface for risks. They look for your network, your assets, and software that you have for any vulnerability that exists. There's the CVE database, CVE scoring being assigned to vulnerabilities. And these tools will represent and say, look, I scan your network, you have this and this operational, and we know that there's a vulnerability with score 9.3, so you really need to look into this. These are the vulnerabilities that we know of, so the known threats, let's say. Cyber asset attack surface management is really, so SASM is really about having an overview of your assets and knowing what you have in place in order to prioritize more on what is really needed in terms of, let's say, prioritization for patching, etc. You basically connect different data sources that you have in your environment in order to have a full overview of the assets that you're running, so you have an idea of the attack surface management that you're facing. Because this is what the attackers are going for. They're going into your environment. If we start from a assume breach position, they will have that initial access in your environment, and from there on they are looking in reconnaissance for your assets. They do a discovery and search for whatever you have in order to continue their path and their exploration of your environment. It's important that you know as well what you have in the environment, and that's what SASM is all about. That's stuff that we discussed already in the past in previous webinars and previous sessions, vendor agnostic and vendor specific. Today we're going to introduce a few new terminologies. One of them is attack surface management, of course, which is a term that has been already around more in the wild. I've seen more and more, but it's really about the continuous discovery and monitoring of let's say your attack factors in your organization and as well as external, and it's EASM. We also know that as digital attack surface, right? So it's really about your internet facing assets and the attack factors that can be exploited during this attack. Breach and attack simulation that we're going to discuss more and more today. I will also show you today with the Cymulate platform. is really about detecting and alerting on the threats and confirming that they can be exploited by performing real attacks on the threats that you have. So no techniques used by adversaries in the wild, and simulating the attacks on your environment itself in order to see if your security controls in place are defending well. And then we have CART, or C-A-R-T, continuous automated red teaming, which is more specifically focused on doing an entire attack path on your environment. So not individual, let's say, techniques, but a full attack chain from initial compromise. For example, you start with phishing and later on doing lateral movement and data exfiltration. So like a red teaming exercise, but then in a continuous automated way. These are the stuff that we're going to discuss more in detail today, and Stan is going to start with the attack surface management.
All right. So attack surface management is really a term that covers a lot. But first thing first, we're a big fan of the golden circle from Simon Sinek. That means we're gonna focus first on why we are doing this. Then we're gonna talk about how are we doing this, and then the what. So why? Well, it's quite clear that our attack surface changes all the time. We have a hybrid environment. We have an ever-expanding attack surface, which makes it almost very difficult to protect, even with the right tools. Such hybrid environment with valuable data everywhere, and people are everywhere, and everyone can have more entry points than you would like or even know. So there's no one-fits-all solution. That's why we need a combination of tools. They've already talked about CASM. We're going to quickly touch this because we already did a session about this, but also about external attack surface management, and more specific also breach and attack simulation. So the whole idea is that we will continuously discover and monitor everything in our organization and evaluate all organizational assets. And the keyword is continuous, because this is a loop that we're going to do again and again, because our attack surface, our entire perimeter on-prem in the cloud is constantly changing. So that's why we really need to do this again and again. That's what you see if you go to the global overview of attack surface management. First part is discover and monitor. So again, we did a session about this with Exonius. There was a focus on discover and monitor, and also identifying your risks. Now our focus will be also identifying those risks, especially from an internal attack surface management point of view, but also really to perform adversary tactics and techniques in an automated way. Because of course, we're gonna say that this will not replace pen testing or red teaming at all. It can help and enhance it, but we want to do a continuous action or path that we're going to take, because this is a circle. This is going to keep coming back again and again, because your environment is changing all the time. So cyber asset attack surface management, it's a big word, a lot of words, but the idea is, why are we doing this? Because you cannot protect what you don't know. We have all these assets and users out there. They're roaming the entire world. They're using dozens of SaaS applications, maybe applications you didn't even know of. You get bringing your own device, your IT environment, IoT, even OT sometimes. So very mixed environment, and you have that lack of visibility. So how are we going to bring that visibility back? Is collecting with every existing data source in your network you already have. That's the whole idea. You have all that data. Now you need the correlation of that data. And if you do that, you will get an unified view of all your cyber assets, and will give you the power to then identify all those security gaps. Is there software missing? Are there some vulnerable CVEs out there you don't know about? Maybe non-managed devices, etc. So that's the whole idea about SASM. But focus today is our EASM and our breach and attack simulation. So external attack simulation is very important, because we could already cover almost 50% of the cases where they use the typical initial attack vectors. And for example, here the exploits and internet-facing servers are already responsible for 40% of all the attack vectors. Credential theft is also a very big attack vector. Those credentials are being sold maybe on the dark web. So that's why there's a technology, or there are vendors out there who will give this as a service. They will scan your internet-facing assets. They will crawl the internet and the dark web on forums to see if there's anything related to your company out there. So really focusing on those internet-facing assets, all those exposed servers, credentials that are out there, maybe the SBOM, so a software bill of material with all those vulnerabilities. that's out there. And then the breach and attack simulation. So that's a part we're going to focus on today. This is just a quick intro. Davey will go more deeper into this. But the whole reason why we're doing this is just we want to test our security stack on efficiency and effectiveness. But also, we are in a changing environment, so just to detect any configuration drift. How are you going to do that? There are different ways. There are different type of vendors, but the idea is that we will deploy agents or nodes in your environment, and in that way you could test the entire security stack, and that security stack will report also to the brain, and that brain is then of course that console that will say, okay, we see your EDR is responding in this way, your firewall is responding in this way. We can do that by a combination of API and syslogs. In that way, the brain gets all that information. So the whole idea is that we're going to use those tools to get a deeper understanding of your security posture, all those vulnerabilities, automated testing. In that way, you get a whole overview of how will you respond in your environment to such an elaborated attack.
All right, if we're looking at, or we're talking about breach and attack simulation, we're talking about simulating attacks and trying to look at our security posture and see how well our security tools are doing. Now, what we did in the past is it sort of started with vulnerability assessment. We'd already talked about it when I was talking about abbreviations and the terms. But vulnerability assessment is really about looking for vulnerabilities in your network, on your software assets that you're running, on your endpoints. Software is running there, and all kinds of vulnerabilities come out, and they, like I said, they get CVE scoring. That's really where we started. After that, of course, we realized that it would be nice if we could start doing some real analysis and testing, or security testing of what we have in place, of our security tools, firewalls, ADRs, NDRs, etc. This is what we did with pen testing, some red teaming exercises as well. But of course, it's a one moment in time exercise, and it's been done and then reported, discussed, etc. It takes quite some time and quite some expertise in order to do this. From all of this, breach and attack simulation really was born with the idea of making sure we can automate at least a big part of this to have a continuous feedback loop of what we're doing. So a little more extra on the difference between breach and attack simulation, red teaming, and pen testing in general. Starting with pen testing. A pen test is really something that is done by well, experts in the field. We call them pen testers, of course. And what they do is a manual testing, really specifically, most of the time specifically on a vulnerability assessment, let's say. So they act on a very specific defined scope to begin with, and everybody's aware that this is going to happen, right? So they're not focusing on the stealthy approach. They don't care if they've been discovered. They really have a scope that they need to look into. For example, test a few vulnerabilities that were exposed, and you know that you have the software from your SASM tooling, so you want the pen tester to really test out this specific part. It's about testing the effectiveness of your vulnerability management, security controls that you have in place. This is in contrast with red teaming, where a red teaming exercise is really it's not scoped, but it has a specific goal. For example, you want the red teamers to start with an assumed breach position, and they need to gain access to a sensitive server and exfiltrate some data from that server. They have a goal to achieve, and the blue teams are allowed to act, right? So they're not really aware, or they are aware, but at least they're not doing anything specifically extra, because they know the red teaming is taking place. But the red team guys are also pen testers and guys who have a lot of experience in doing these attacks. They use APT techniques, so the TTPs that we discussed from the micro attack framework and being used by APT groups in the wild. They use these kind of techniques to achieve their goal, to move lateral in your environment. And the blue team is allowed to intervene, right? If they see stuff coming up in the SIEM, or the SOC has an alert, they are allowed to act on it, push the red teamer back, and then he needs to find another way. This is really the exercise of doing a red teaming, a blue teaming exercise. And when it's done and they come together, of course, they can share information. That's where the whole purpose teaming term came from. when you're talking about this. So very specific, on a goal, also stealthy, and trying to do real world attacks, trying to simulate them. So what is breach and attack simulation then? Well, it's actually a sort of a mix of all, where you also start from assume breach position, and you start testing these different kind of techniques or threats, if you want, in your environment, and try to simulate a full attack cycle. Right? There are different components in an attack cycle, a full attack chain, the one you know from Lockheed Martin or from the MITRE framework, the different tactics that exist. Can try to, the breach and attack simulation will try to simulate a full attack cycle or different parts of it to evaluate your posture, but it happens automatically, right? It happens at a continuous pace. You can run it, for example, daily or even faster. You can directly test different components of your environment in order to have this continuous view, in contrast to a single point in time visibility or report. So that's very interesting, because from the moment that you actually start doing real-time automated attack simulation, the continuous evaluations, you have a view on your attack post, on your security posture, and maybe you need to modify things while it's happening and see, okay, we need to fine-tune these security tools. We need to make changes there. Maybe you need a new tooling because you're not covering things at all. What happens when breach and attack simulation is done is basically put it in sort of templated attack chains. And the nice advantage of this is that this actually can be done by security analysts who have a wider skill set, maybe even blue teamers, and you don't need to be a specific red teamer with a lot of expertise in doing red teaming or pen testing, because the tool is giving you the layer of doing this and the layer of abstraction of doing these kinds of simulations. Maybe you're familiar with other terms like adversary simulation and purple teaming. Breach and attack simulation comes very close in this. There are, of course, subtle differences, but I hope you see the difference here in BAS, red teaming, and pen testing.
So the term security validation, it comes from because we do a lot of assumptions. We assume that what vendors are claiming is true. We assume that our products are implemented in the right way. We also assume that people don't make mistakes. And we definitely assume that policy changes are well documented and communicated. I think this one answers it all. Never assume, because it makes an ass of you and me. And that's really the case. We do make a lot of assumptions, and we do trust that people do the right way, but in reality, that's not the case. So that's why we need to validate stuff like this. And if you look, okay, breach and attack simulation, where does it fit? Depends who you're asking. If you're asking this in the typical SOC maturity, they're gonna say, okay, this is by the end. If you have all those investments in place, we will do the breach and attack simulation on level 5. We don't actually agree with this, because breach and attack simulation can really help you already much earlier. Why? Because it will also show you your gaps and where you should invest first, because not every environment is the same. Everyone is doing this in his own pace, and it's very important that you see, okay, these are gaps that I have, and this is most critical at this point to invest in this type of technology. So that's why we don't really agree that it is only for level 5. Okay, this is for the more mature companies or companies that are investing in going to the right direction.
I think even that it makes more sense to do a breach and attack simulation before you start specific red teaming or pen testing exercises, because you can really do them like what you see here is already from the level of when you're starting to do your security automation and you have your advanced analytics. This is really the moment that you can start activating these breach and attack simulation tools and let them already run a few tests, even before you do a very specific red teaming exercise, because it will give you a feedback loop. It will tell you what kind of security tools and which kind of tools you need to fine tune, and then let the red team guys try to bypass it in a later stage.
Yeah, it's a good investment as a practice exam, because those pen testers are really going to go out there to see what they can get. If you look at, okay, now the why these are the use cases. What are quick wins to say for yourself as a company? Why should I do this or invest in this type of technologies? First of all, the security posture and readiness assessment. You can really leverage this type of technology and then use it to the MITRE attack framework to categorize your findings and facilitate a discussion about, okay, how well am I performing? Where should I invest first? So that really helps you. But also to validate that your controls are well implemented and very efficient in how are they detecting and maybe even protecting it to those type of attacks. And like we mentioned before, complement penetration testing. Penetration testing and red team is very good, but it's like a snapshot at a certain time. We do it maybe once a year, once a quarter. If you do continuous validation, you can do this, like David said, every day, every week, whatever, depending on what you like or what license you're gonna buy. So these are the really quick wins, and also very good to communicate to C-level because it helps them. They're going to be assured that what you guys are doing in the team is being proven by this technology, that you're doing it in the right way. But it can also help you building a case for buying new technology when necessary. And in the long term, we have a lot of other wins that we can get. If you look at risk-based vulnerability management, Dave will go deeper in that, but know that there are more than 500 CVEs every week out there. So you need to know which CVE is critical for me in my organization. And for example, Cymulate can help you with that, with really showing you what is most critical at that point. Another one, like Dave already mentioned, red and purple teaming would be a huge benefit. But also with mergers and acquisition. If you have a company and you're buying a new company, and you're gonna give them access to critical infrastructure, you want to know how well they're performing. You want to really see how that team is reacting to it. It's also possible with this technology. The same for third-party assessments. If you're gonna buy a new technology, why not use breach and attack simulation to test it out and see how it's responding. And after all, it's all about building your security team and using SecOps processes and training your staff about how to write policies, how you're going to respond if there's a threat. So that's a good tabletop exercise, and that's critical for incident response planning. Very quickly on the how are we going to do that? We have a portfolio of simulated attacks. It gets updated, I think, almost daily for the better vendors out there with the most critical attacks we see out there. Ideally, you're going to use a SaaS platform because the amount of resources you're going to need it also needs to be scalable. You can deploy software agents, VMs in the environment, and it's all connected through API unlocks. In that way, you get all that information about how well are you responding, and then you have detailed reports, and on that detailed report you can work on, and then you can improve and do it again and again. This is an exercise that will never end, but it will get easier, of course. So what are you actually doing? Are you deploying agents and network appliances in your network, on your endpoints, on your servers? In that way, you will connect your entire security stack to the like called the brain or the SaaS console, and in the end, you will be able to run multi-stage attacks and fix where you're failing at that point, because you will fail, but that's not bad. Some people are more protective and think that this type of technology will show you where you failed, but that it makes sense. You're gonna fail at some point. It's an environment is ever changing. It's very difficult to configure everything correctly. So you want to know before something happens that something is wrong, so you can fix it. And that's the whole idea with continuous security validation. You want to make an assessment first. So assess how well are you performing. See you have a good baseline, and you're gonna optimize, because this will show you that some technology maybe is not doing what it's supposed to do. Is your vendor lacking? Is that type of technology lacking? For example, is maybe an on-prem proxy is not doing a lot anymore because we're maybe roaming out there. So maybe you should invest in a cloud proxy. So you will have something actually to go to your board and rationalize this type of technology is not that good anymore. We should invest in something new. And that way, you're also assured that right now your tech service is under control. You have more visibility, and you can measure the effectiveness.
And that's what Cymulate is putting its focus on. Right? So if we look at how they do this continuous security posture validation, what basically is there are three main topics, let's say. So first of all, indeed, security posture validation, where you look at the effectiveness of your tools, looking at SOC and validating how the SIM is operating, basically your security stack, how is it doing in response to automated attacks in general. There's cyber risk exposure management. How is your attack surface doing? It's evolving, of course, because new vulnerabilities occur on a daily basis. How are you coping with this? How are your tools covering you? How is your risk exposure at that time? Risk is a very, very specific topic, but very important one, especially also to talk to the board in your company and can you present like this is a risk that we have at this time, and it's not only focused based on some CVEs coming out, but really on real life attacks that have been done in order to assess them. And then finally, of course, the policy enforcement done for your security stack. You have different components. You have the network that you need to defend, identity and access control, endpoint security, servers, cloud security, etc. All these have policy enforcement in place, and it's all about validating how well these policies are, and then of course you will need to tune them, I'd say almost on a daily basis, because new kind of attacks are coming out, new kind of techniques, and you probably need to like update certain policies or adding new components if you don't have them in place yet. So this is what Cymulate is about. It's what Cymulate is covering, with the fact that they're doing these breach and attack simulations, they're doing this red teaming, automated red teaming exercises by looking at your environment from the external, but also from the internal perspective, and doing a full kill chain attack on your environment. What Cymulate is not, it's important to mention, it's not a pen test. I hope by now it's with what we explained, this is clear. It's also not a replacement for red team. There is an automatic red teaming component in there, but a very specific red team, as we discussed, has a goal, and it's of course not that. So it's not replacing these the red teamers with a lot of experience and knowledge. It's looking at doing general techniques that are known in the wild to do and to release them to your environment. And it's an attack simulation tool. It's not a vulnerability management solution, although there's a component to work together with vulnerability management tools to show you what important CVEs are and look at your attack surface management. But it's also not replacing any EDR, NDR, SOC, or SIEM. Right? You have these in place. This is your security stack. Simon is going to test them and try to give you a view on how well they're performing. So a little word before we go into the demo itself is about the different components that you will see in the Cymulate platform. So it starts with attack-based vulnerability management, or ABVM, and this is about vulnerabilities, the CVEs coming out and giving you information on which CVEs and which vulnerabilities are important in your environment, so you can prioritize which systems you need to patch because you have them, and Cymulate assess them as we have threats being run in an attack simulation that actually exploit these CVEs. Now, the information from the CVEs comes from vulnerability management tools, the ones you already have in place, hopefully have in place, that are actually scanning your network for vulnerabilities. Some is not doing that. They integrate with these vulnerability management tools to get that information and do the correlation between the tests that you have been doing and the CVE information that is coming in. Next, there is the Cymulate scenario modules. Right, so I will show you later in the dashboard. This figure will come back. This is the a part of the Cymulate dashboard, actually showing you the different modules that Cymulate is able to assess today. It starts with attack surface management at the left side. What basically it's doing is checking your exposure. It's checking, for example, your public hosted web applications for any exposure, vulnerabilities in tools being used in that, from SQL injection to cross-site scripting, trying to exploit your attack surface management from the external for the external world, basically internet-facing applications that you have. It's also about intelligence gathering, by the way, looking at what you're exposing on the web itself. Then the next phase are, for example, phishing simulations and malicious file delivery. It's about email. I think you're all familiar with phishing or spear phishing. This kind of simulation is important because it's still one of the biggest, if not the biggest, initial access vector out there, and you're looking at what APTs are doing in the wild. So it's important to have these phishing simulations and see if the users click on it, and that's what Cymulate is testing with this module. And then related to that is the email gateway validation to see if malicious files can indeed be delivered, if emails with malicious URLs can indeed be delivered to the end user, and if the email gateway is stopping these, yes or no. Further on, we have web gateway validation and web application validation. It's web gateway will check if the user, for example, when that URL with malicious file or the malicious URL is delivered, if the user clicks on it, will the web gateway stop them through URL filtering or validation of downloading of malicious files, yes or no? And then, of course, a web application firewall, again, for the external exposure of web applications. It's based on the OWASP security flaws that are known and out there to validate if your web application firewall is indeed stopping, for example, an SQL injection or a cross-site scripting and other kinds of web-based attacks. These are part of the initial foothold, so the attacker trying to access your environment with initial access. Then we have endpoint security, which is very important and an interesting aspect where, of course, a lot of techniques that are known in MITRE are focused, a lot of them are focused on endpoint and trying to breach the endpoint, dumping credentials from memory, releasing malware and them doing common execution, etc. This is what the endpoint security validation is all about. I will show you later on an example of a run that we did in our lab. We have the hopper module, which is about lateral movement going from one system to another. So from the assumed breach position, a attacker has initial access to your environment. He owns an endpoint. How can he move from one system to another in order, for example, to exfiltrate data from another system, which is in the data exfiltration model. You're looking at sensitive data leaving your network and how, for example, DLP modules on firewall can try to stop this, that this information is leaving your organization. Everything you see here is basically built on the Lockheed Martin attack kill chain. Right? You go from recalling to infiltration, initial access, compromising systems, privilege escalation, lateral movement, and in the end, data exfiltration or ransomware deployment. And this is also what this dashboard represents. Furthermore, Cymulate focuses on the kill chain scenarios. So it starts with immediate threats, which come in, like Stan already mentioned, on a daily basis. We'll show you that, for example, there are new ones coming in as well today in the platform, new threats that have been seen. The security analysts from Cymulate, they look constantly on the web, analyzing APT behavior, look what kind of new techniques that they have been using, and putting them in threats, updating your platform that you have, the Cymulate platform, so you can start assessing immediately on your environment these threats and see if you're protected, if your security tools are covering them. This is an immediate threats. Then we have also scenarios and campaigns, so really full kill chain scenarios and campaigns that can be run, what APTs are doing, the real world advanced system threats, and simulating them, and in the Cymulate scenarios and modules. You can even build them yourself and try, say, okay, I want to take a few specific threats and try them after each other, see how we cope with that. So that's already a bit more advanced. You can see this scoring. It's important to just take a minute and explain what these scoring levels are. You've seen them in the previous slide, you've seen them in this slide. There's an overall score, in this case 55 on 100. What does it mean? Well, the scoring level in Cymulate is split into 4 levels, as you can see here, and the higher, the worst, let's say. So a low score is a good score, which makes sense. The way it is calculated is with an algorithm, of course, based on all these assessment and threads that are running in the platform, based on a few models and framework like NIST, CVSS, RED, MITRE, and others. There's a more detailed explanation given by Cymulate on how the calculation is being done. It would go too far in this webinar to explain it, but it gives you an idea what this really means, because 55 on 100, it's a medium risk score, but is it bad? Is it not bad? Of course, not good. And it's important also to look at the specific modules and try to improve on that level, or you need to really improve on that level. That's where they are in high risk or medium. So every scoring contribution is calculated per module, and the overall score is then calculated by looking at these individual module scorings. For example, one example to give you an idea, if we're looking at immediate threats, so the red square that we have in the image on the left, where a new technique is coming in the platform and being tested, they're looking to calculate the score. They're looking at what is the risk of this attack, the risk of this threat, and what is the penetration ratio. And with a little algorithm or a little calculation there, will give you a scoring, and if the threat was successful, it will be added and, for example, give you a value of 60 or 70 if it's a high risk one. And all these different scorings lead up to the final score that you have on your Cymulate platform. Advanced scenarios. So we're looking into, talked about scenarios that you can do full kill chain attacks. The advanced scenarios really allow you to customize your assessments that you want to do. The whole idea is that you simulate what an APT is doing. You'll use different scenarios, different threats that are available in the platform. They are provided by the platform itself. You can build your own using a subset of TTPs and try to assess a full attack kill chain from beginning to the end. An attack and see how well you're coping, how well your security tools are covering it. Of course, it makes sense that this is based on the MITRE ATT&CK framework, and there's also, of course, the MITRE ATT&CK mapping in the platform itself. As you can see here in the screenshot, showing you the coloring scheme of how well your environment is dealing with these techniques and these tactics. And then finally is the campaigns or the card continuous automated red teaming, where you actually link different modules to each other. And for example, start with the ASM, go to phishing, where you start phishing a user with a link, and then when they click, or a file, and when they click on the file, it's malware being delivered to the endpoint. And then Cymulate will try to execute it and do a lateral movement using the hopper module to another system, etc. Again, you can build these full kill chain campaigns yourself using different models. If we have time, I will quickly try to show this to you. But a very interesting one to see, like, how can you can really start simulating your own kinds of campaigns and or using existing campaigns that are known and also described, for example, in MITRE, and execute them on your environment itself using the Cymulate platform. Now, before we go in the demo, I will just give you a short overview of how the architecture works, because it's actually pretty simple, right? As Dan mentioned in how you're going to do stuff when you're looking at breach and attack simulation, so you need a SaaS platform. That's what Cymulate is. It's a SaaS platform where you basically install one or more Cymulate agents in your network. The agent is doing outbound connections towards the SaaS platform, and he will do all the assessments, do the simulations, do the lateral movement to the hopper, try to do the download files, deliver malware, etc., and we'll give that feedback to the SaaS platform where everything is analyzed. Now, files, C2 communication, phishing emails being sent are done through the Cymulate AWS cloud, where the database is in place with everything with all the techniques, etc., that you can use, and everything is there with email gateway listener, the web application firewall attack server that will do the attack. So we'll tell the Cymulate agent what to do. Or WAF will be for external, of course. So the agent will instruct the WAF to do that. But looking at downloading files, the Cymulate agent will get his files from the Cymulate web service as well. And then there's, of course, email gateways that the emails are sent to your email gateways in order to test out if they're covering it. So in terms of architecture, it's pretty simple from let's say customer point of view. When you're looking or you're working with Cymulate, you're really working with the agent, installing it on a specific server. For example, I installed one in the lab. We have it on a Windows server and we have it on a Linux server. So we can do different kinds of attacks, the Windows specific ones, the Linux specific ones, and that's about it. Then you have the agent running. You do some integrations, which is not really in this slide, but you link the integrations with like EDRs that you already have or SIM solutions that you have, the vulnerability assessment tools that you have in place. You just do it also through the SaaS platform with API keys, filling in, linking. It will say it's connected, and then the information is also ingested in the platform itself. So enough said, enough screenshots, enough talking. I think it's time to have a look into the Cymulate platform itself and show you what it's all about. I'm going to show you. Oops, I need to log in. We've been talking too much, and this is the result. So I'll just quickly see if the environment is still up and running. I have two environments. One running in our own lab, and one is a demo instance of Cymulate itself. I want to start off with the demo instance of Cymulate because that will it contains a bit more data, and it's interesting to show you a few things there. But to show you the real testing that have been done on the lab, I will pivot to the environment that we have. So this is a Cymulate demo environment, and it already recognized. You already probably recognize the dashboard that I showed you. I'm going to make it a bit bigger. The dashboard that I showed you before with the different modules in place. But let's start with so at the left you can see different dashboards that are provided by Cymulate. So the Cymulate dashboard is this one, but you have different dashboards depending on what you want to see, and you can build your own. Right? It's important that you know this because then you can really specifically build a dashboard, focus on a specific threat or attack kill chain, and then you have that visibility right there, one click away. Looking at ABVM or the attack-based vulnerability management dashboard is what I talked about with vulnerability management and the integration of your vulnerability assessment tools with Cymulate. For example, what you see here is a list of CVEs depending on their CVE scoring and giving you a priority based on the threats that are related there and are running your environment. For example, CVE 2021-44228, wild guess, but it's Log4j. Right? I don't remember the numbers myself as well. Luckily, there's an information sign telling you it's Log4j and what it's all about. We're not going to read this in detail, but you can see here that it's a critical vulnerability, and it's actually been tested because there are some threats that are in Cymulate that can be run tested. They already have been tested, and you can run them again if you want, related to this CVE. So it's not only one because CVEs are more complex and they cover specific vulnerability, but depending on different attack angles, let's say, you can have different types of testing, and this is what's done here. You have a critical Apache Log4j vulnerability being exploited in the wild. It checks out the endpoint security validation, but also web gateway. There's some tagging to find it in the platform as well, but you can also have it, for example, is being used in the dry text banking malware, again covering endpoint and web gateway, but it's a different approach, a different threat that can run in the Cymulate environment. And this is done for all the CVEs that are available. For example, here there's a max exploitation of the Bluekeep RDP flow. So this is a vulnerability related to remote code execution in remote desktop. And all these tests can run in your environment and give you this overview of where you are. Going back to the Cymulate dashboard itself, again, as I explained, the different modules with their scoring. Each module, you can click on it and you can ask for more details on what's been going on. So you can baseline and say, look, this is our score. We did everything we can. We have a good baseline. Let's set the baseline score. I'm not going to do this now. You can look for the latest campaign that has been running for this, and of course the next assessment. You can schedule your assessments or you can run them manually. If we go for the history on this, we can see that there has been a scan in April, checking. So we're looking at ASM, that means we're looking at the attack surface management. So a domain has been scanned and 2 outbound IPs have been detected for this scan. Let's look at the results here just quickly. We're not going to go in detail, but as you can see, there has been a discovery of assets. The top assets are it's acme.com, so it's a simulation. there have been different vulnerabilities have been detected. So that's not good, let's say. So it needs to be working on this to make sure that they're covered. Again, you can see the assets, everything that has been discovered for this company, and the findings show you actually the results of these scans. There they are, showing what kind of issues have been found. For example, vulnerability software in use. Let's take the first one. It's a service-based one, just on the website of the company itself, but it's a critical one. You can start investigating, so change the action. But if you're going in the more info screen, you will actually see what this is about. It's about the fact that jQuery is actually is out of date and is being used on this website, and it's publicly exposed and available, so it can be attacked by an attacker. So that's something that needs to be fixed. With this info and this reporting, you can go back to the guys managing the website and say, look, you need to fix this. This is what our attack simulation tool will find out. We are vulnerable at this moment, so we need to fix this. And there are other kinds that I can see. For example, an email address was actually hacked. It was detected that this email was compromised, for example, on dark web or other resources. Let's go back to the dashboard. So looked at attack surface management. I'm going to show you these in my other environment where we did some simulation on it. But interesting to see is, for example, the breach attack simulation itself, right? So as we explained, it has two components, the scenarios and the advanced scenarios. They make up the scoring right here at the right side, so the immediate threats and the full kill chain and scenarios and campaigns. Now, looking at scenarios, what is interesting to see here is that these scenarios come in, as we said, on a daily basis. For example, recently there was a 3.6 vulnerability or a supply chain attack. These are the IOCs that came in Cymulate. So you see 130th of March, and then in April, new IOCs have been coming in. For example, because Lazarus Group has added Linux malware to its arsenal in Operation Dream Job, right? And if you want to know more about this, you can click on this and start reading on the details of this, of what it is about. But it gives you an idea of the threat and what's going on. It will show you information, a summary, let's say, on what is it about. So CrowdStrike Sentinel-1, they observed, they saw this happening, they analyzed it. Give you a short description of what happened, the IOCs here, and if you click on the link, you will end up on the, in this case, Sentinel-1 blog page, actually explaining what happened here. So, of course, now and then, when you're in security analyst or in the blue team, you figure out or you see this kind of blog post, but here you have one platform actually telling you, hey, we have a new threat coming in. This is what it's about. Click on the link if you want to know more. If you have time and you're interested, you can start reading all this, because this is what this threat is about, and then you can see it. It's pretty detailed and advanced stuff, because it's about the vulnerability, about a threat that can be exploited. And then you can start running this one. You can start assessing your environment. You can see for the attack matrix where we are, and here you can say, let's run this on one of our targets. Now, again, this is not my environment, so there's no target here, but you can try assess this on, if you're a 3.6 user, you can start running this on all your 3.6 desktop or desktops machines that have 3.6 installed. And here, for example, is where you can see that new threats are being added, right? So this is from yesterday, this is from tonight, 5/64. There was a new threat added. It's Python-based loader masquerading as OneDrive utilities to drop multiple rats. Make sure you run it, right? So a new threat came in. We get an alert on that, that it's present, and from then on you can say, I want to launch this, but it will also be part of a later phase where it can be automatically run by the ones you have already scheduled. You can see in the BAS module the different modules again here, but you can also see the full kill chain scenarios that are in place. These are actually doing what was discussed before, these kill chain scenarios based on these threats. So, for example, I don't know if you know the Fin8 APT group, but you can basically say, this is Fin8, this is what they do. Let's run if you want, like, for example, email with malicious word attachment containing a macro, it's running PowerShell, doing the OL injection, etc. Let's run this on my environment, see how we deal with it. You can start building new templates, putting in your own information, your own threats, But actually it gets interesting when you go to the advanced threats, because there is where you really can see how you're dealing with these different advanced scenarios in the full APT attack chain on the MicroAttack framework. And this is based again on templates. There's a whole bunch of templates being provided out of the box. Let's say, for example, we go for APT Advanced, and here you could really dive more deep into the details of how a certain APT group is working and was looking for Lazarus, for example. We can view a summary of what these guys are doing, where they're covered in the AttackMite framework, so which phase is going to be tested, to the different scenarios here to the right side, from keystroke input capture to data exfiltration to our Windows files, stop services, etc. So this is all going to be done in this scenario. And if you really want to know how it's working, you can actually, well, let's say, to run the test yourself. Most of these tests, of course, need some parameters to start with. Again, we're doing an assume breach position here. We're taking an assume breach position, so you need to fill in some details. You go for the next phase, and you can start running the assessment of your environment itself. So that's the BAS component. And final component is the card component, where, as we discussed already, you actually go through a full kill chain campaign, where you really start, for example, looking at the APT wrapper hopper, or you're doing a APT BAS test, which tells you, okay, I'm going to do a phishing attempt. It's a full test. We're going to do a phishing attempt, or in this case, phishing email, and using Dropbox templates. So people click on it. We're going to deliver a file, and we're going to exit the file. You're going to download the stager, and these are the different phases in the attack that's going to be executed, and see how well we are covering against that again. So let me change environment here and just show you what this could, or what the result of this kind of attacks are. So one of the things that we did was, and well, maybe start with web gateway, is web gateway testing. So as you can see here, I have a score of 100, of course, because the lab has no web gateway. So there's nothing in between. There's no firewall or whatever. That means if I go to the report, Cymulate did a test and everything worked. Well, we only did file tests in this case, and you can see that 47 files were successfully downloaded. We can go in details. These are the files that have been downloaded. You can see details of what this file is, and as we discussed with the architecture, it's coming from the Cymulate Amazon resource, because of course it's a safe test. This is not real malware; it's mimicking malware, but it's been successfully downloaded, and there's no web gateway that has stopped this file being downloaded. There's a bunch of files. You can add your own files if you want. If you want to test a specific file that you've seen, you can add it and run this test again. Next phase, for example, is the endpoint security. You can see a 1400, so we can check why this happened. If we go to our history, you will see that we did a few tests. The latest one is from May. This one was completed. If you go in details of what happened here, you see that we did a test on ransomware. Not a lot was completed, 3 of 27. Why? Because our EDR was active and alive. Of course, with some exceptions, because we wanted at least to have something bypassed and successful, and also new stuff maybe that was in there. But for example, you can see here that the different attacks that are being executed in this simulation, so it's quite a list, pure focused on ransomware. If we go into the more info, we will see the different steps that have been taken, going from a command line execution using the Windows control panel to load the DLL. The DLL was then loaded. A .NET CRL was loaded after that in memory. Folder was found. There was an encryption key generated, and there was an attempt to encrypt the files. This was all completed and not seen. Why? Because we have an EDR, in this case Sentinel-1 active, but it's in alert mode only. So we do see IOCs here popping up. We can go to the event alert showing us the ones that we need to query from our EDR, but it is an alert only mode, so it allowed this to happen. So this is an interesting component. You see the integration with the EDR in place. You can see the different steps that are executed in order to do this ransomware attack in detail. with even component, you can get more information on the detection, on the mitigation, the analysis that you need to understand what this is about. This is really already for security analysts, of course, SOC people, and even start generating Sigma rules for whatever SOC you have, tool you have in place if necessary. So just an idea of an example of how an endpoint security validation report looks like. And then maybe to end with is, for example, immediate threats. Looking at the support here, it will show you again the same fact that we did a Moloch ransomware. In fact, we just did one to give you an idea of what's going on there, and it will just execute the disbat file. So we took a very specific one just to have it quickly done, and you can see that it also was successful and gives us a bad score of 100. So a lot of stuff in the platform, a lot of simulations can be run. I think we're going to end up the demonstration here. We're going to do more in detail later in specific sessions. We just want to give you a quick overview of the platform. We hope it's clear that what it means and how it can provide value in validating your security posture, and that you can fine tune your security tools with the feedback loop that you get from this type of platform. We're going to end up the demonstration in this case.
All right, thank you, Davey. So you saw the demo, you saw what use cases we tried to tackle. What's next? Well, depends on you. If you really like this, you say, okay, this looks cool. Okay, great. Reach out to us together with us exclusive, but also with people of Cymulate. We were able to arrange a meeting. We can come by. We can talk about, okay, how does the licensing work? More deep dive. But we are also implementing this in our own lab. So this summer, we're going to take some time to really play around with the technology and go deep dive with all of our different technologies so we can have a cool lab setup. And then later on, we can do sessions that really go deep dive technical, but also the sales tracks, because Cymulate is really interesting for traditional resale, but also for MSSPs, because you can really show your value as an MSSP in improving your services, improving your SLAs, and really just making an impression with the customer about how mature you are as a security partner. So stay tuned, because we're going to do a lot more with Cymulate. Thanks for joining us today, and see you after summer.
All right. Thank you. Bye-bye.